Mae'r cwestiwn yma o papur Mehefin 2014. So this question is from June of 2014. It's a PH1 paper. Byddwn ni'n cychwyn hefo state the principle of conservation of energy. Okay, so I read on Saesneg. Energy cannot be created or destroyed, only transferred into other forms. Again, Gymraeg, ni ellir creu na dinistrio egni dim ond ei drosglwyddo o un ffurf i ffurf arall neu i ffurfiau eraill. Just diffiniad i hwnna. Reit. Mae'r cwestiwn nesaf wan yn gofyn I ni esbonio sut mae o'n gymwys I wrthrych sy'n disgyn trwy aer, mewn bold. Explain how the principle applies to an object falling from rest through air, and the through air is in bold. So that means that air resistance is not negligible. Dydy o ddim i'w anwybyddu. Felly, beth sa'n ni'n gallu dweud fysa, wel, mae yna un grym sy'n gweithredu drwy'r amser ar unrhyw wrthrych. So, y pwynt cyntaf I roi ydy mae gennych chi pwysau am I lawr. So, mae o ar safle uwch. So, initially, the object has gravitational potential energy. Mae ganddo fo egni potential disgyrchiol. Wrth ddisgyn, mae hwn yn newid I egni kinetig. As it falls, the object gains kinetic energy and loses potential energy, or gravitational potential energy. Wedyn dau farc neu dau bwynt da ni wedi reid o fanna man. Mae'r trydydd pwynt yn dod o'r beth sy'n fama, through the air. Wrth efo ddisgyn drwy'r aer, mae'n gorfod gwneud gwaith yn erbyn gwrthiant aer. As it moves through the air, it does work against air resistance. A beth sy'n digwydd i'r egni ydy bod o'n cael ei drosglwyddo I gronynau'r aer. Hynny ydy mae'r gronynau nwy sy'n gwneud yr aer yn ennill egni kinetig. The air particles or air molecules gain some kinetic energy so that the final EK of the object is less than its initial potential energy. Right. In practice one felly, scroll up again. We've got a child of mass 16 kilograms starting from rest at the top of a playground slide and reaches the bottom with a speed of 6 meters a second. The slide is 4 meters long and there is a difference in height of 2.4 meters between the top and the bottom. Wan, beth da ni eisiau sylwi di, mae o'n 4 metr mewn hyd, 4 metr mewn hyd, a mae o 2.4 metr o uchder, neu gwahaniaeth uchder, delta H, sy'n ni'n gallu gael hwnna. Okay, so the height difference is 2.4 meters, delta H, and the slide is 4 meters long. So the work done against friction is along that 4 meters length, but the potential energy is just the vertical height. So let's work out the potential energy first. Egni potential mg delta H. Wedi bwysio fo? 16 llasu fo 9.81 llasu fo 2.41. Okay, ac mae hwnna'n dod allan yn I need calculator as ydyn. 16 times 9.81 times 2.41 378 joules. Wan, be sgynnon ni yn y gwylod ydy bianedd. We've got the speed at the bottom of the slide, and it starts from rest. So the change in kinetic energy is going to be, well, initial kinetic energy is 0. The final kinetic energy is half mv squared, half times 16 times the velocity at the bottom, which gives us 0.5 times 16 times 6 squared, 288 joules. Okay, felly mae'r egni ar y gwylod yn mae'r egni kinetic ar y gwylod yn na'r egni potential. The kinetic energy at the bottom is lower than the initial potential energy. So the change in energy is the work done, which is the difference. So 378 minus 288. 378 minus 288, 90 joules. So that's the work done against friction. Right, we now need to use your answer to B1, the 90 joules, to calculate the mean frictional force acting on the child. Let's scroll up again. Move that along. So we've got 90 joules. Oops, scroll too far. There we go. 90 joule sgynnon ni ydy'r gwaith. W is 90 joules. The distance along the slide, I'll have to scroll back up to remember that one. Okay, mae'n mynd 4 metr, so the distance is 4 meters. Go back here. Oh, no, just carry on. So the distance travelled is 4 meters. 4 metr, okay. Is 4 meters. Work done is force times distance. So the force, or the resistive force, is work done divided by the distance. Gwaith ydy 90 joules done against 4 meters. Sydd yn rhaid, just check, 22.5. Grym dio, felly Newton. Okay, so that's the mean resistive force, or the mean frictional force. Obviously, the force isn't constant because initially the friction is close to 0 as he speeds up going down the slide. Okay, so on the friction is going to be near 0. Here it's a maximum, but over the 4 meters there's a mean force of 22.5 newtons acting on the child. Dyna ni.